I'm frustrated, really. I have to design a chemical process which I know how it works, but I have to use a solid precursor material that I have to bring into the gas phase. And I have no clue how that works. What? There's a solution? Hold on for a second. All right. So I talked to somebody who has a clue about that. And as you may remember, in one of our last videos, we were talking about a different application. Water as a medium. And the advantage certainly is that water is pretty easy to temperature control, as you have thermal convection in the container, in the vessel. Yeah? And also the interaction between the carrier gas and the medium is pretty well, as the contact surface is very good. So how can we translate, let's say, this into the solid state application that we do here, or that we have to do? A solid is certainly different from a liquid. But what is a solid? A solid can be a solid piece of material. It can be a powder. It can be a granulate. And the question is certainly how to define that. That needs to be defined in order to have repetitive conditions in the process we are running. And there are certainly more differences between a powder and a liquid. Another one is temperature transport. And as said, in the liquid phase, we have a pretty good temperature distribution. In a solid state, it's difficult because the single crystals need to transport their temperature further and further. That happens pretty bad, actually. So the question is how to even reach the most critical part of such vessel. And as certainly the inner part, the core, let's say, is difficult to reach, the idea could be to just take out the core, as you may be able to see here. So if you think, for example, as this being a donut, it's the right picture that you have, because the inner part is the most critical part. Let's take the inner part out here. Another issue might be the enrichment of the medium in the carrier gas. As we have a solid here, the vapor pressure of the solid is very limited. It's certainly lower than a liquid. Yeah? And in order to fulfill the Clausius-Clapeyron equation, we need to bring all certainly at a certain temperature, and we need to establish full enrichment of the carrier gas with the medium. And that probably, most likely, needs a longer travel path. As the enrichment is smaller, we need a longer travel path. And that was what we achieve with a certain staggered system setup that we have in there, as you can see in the animation up there. So that's a challenge. Another challenge would be that we have a so-called channeling effect in this bubbler. Channeling in this case means that you have an initial situation of the crystals to each other, and you have an initial start of the carrier gas flowing through it and an initial enrichment. So in some parts of this setup, the resistance will be lower, and in some other parts it will be higher. So the carrier gas will certainly use the path in which the lowest resistance is, the lowest flow resistance. In these parts, the crystals will be dissolved let's say, in the carrier gas and will be removed. So what you create are small channels in your powder system. And that's the reason why we have a certain height of this process vessel. Because a certain height means a certain pressure, a certain weight on the channels, and that will resolve in the fact that those channels will collapse again from time to time. So that's how we avoid that. With such system, it's also possible to, let's say, operate with delicate materials. Materials that suffer, let's say, from elevated heat. Elevated heat would be what you would provide, what you would use if you have something which is not very sensitive, that you can heat up in a evaporation vessel. But in this case here, you can also use very sensitive materials. So what is a sensitive material? I believe I will come to this point at a later stage and explain it in one of the other videos. So I hope I could show you a bit what are the differences between liquid and solid state process vessels, and I would certainly be happy if you would come across with your questions to our attention and we can discuss your challenges. So far, stay tuned and stay healthy. Take care.